everybody, welcome back. This is part 2 of our learning targets opportunity. In the first video, we talked about what 3D learning performances were and why they are probably a better option for daily learning targets than a huge NGSS performance expectation, or maybe something that's a little not as aligned from your curriculum. I hope that as you watch this video, you're looking for ways to learn how to create such 3D learning performances. And that's what I'm going to do here in this segment. So I'm going to take myself off and we'll begin looking at the steps. So remember that the NGSS performance expectations, those big standards, are three-dimensional. They have the disciplinary core ideas, the science and engineering practices, and the cross-cutting concepts. First thing we need to do is identify what our performance expectation is that we're trying to address in our learning, in our lessons. Then we need to unpack it, figure out what each of the three components are, what they mean, and that will help us better write some smaller, more targeted learning performances for students to do. What does it mean to unpack? Well, let's first look at, again, what the three components are. Remember, the DCIs are the content knowledge part, the key ideas at whatever grade level they happen to be, how much of the science is there, what the science is that's there that they need to learn. The SCPs are what scientists do, that students need experience in doing, so that they can gather evidence and figure out ways to make sense of that evidence. Things like modeling and explaining and using computer simulations and obtaining text that makes sense and is applicable, those kinds of things. And then the cross-cutting concepts are those things that students use to make connections. They help them make predictions, understand what's happening. It's those things that cross over from life to earth to physical to engineering, all science realms, all science ideas that are true for all of them, to help make those kinds of connections. Well, a helpful way to unpack is to create a map. Now, maps can get a little messy, so I suggest that you get some paper, a pencil, and prepare to write down, make lists, circle, connect with arrows, draw boxes, try to form links between the different parts. And I'll show you what the end product of one of those is. It's kind of hard to see it unless you see it in action, but hopefully as I explain, it'll make a little more sense to you. But what it does is it makes the learning performance more evident to you, and it makes more sense how when you take the individual parts, it all goes back into that original performance expectation. So let's get started with an example. This is a 6th grade performance expectation from the standards, Physical Science 1-4. Develop a model that predicts and describes changes in particle motion, temperature, and state of a pure substance when the thermal energy is added or when thermal energy is added or removed. Now imagine trying to make that your learning target and putting that up on the board for your students to try and meet in a single lesson. That's impossible. There's no way they can meet that standard in a short period of time. It's going to require several activities, several experiences, time to process it, time to think about it, time to talk about it with others. All of that needs to happen before they can actually meet this standard. So a good way to do that and to help it be more efficient is to take this standard and make it into smaller bites, like we talked about in the last video. Because if we color code it, we can see that it indeed is three-dimensional. It has the practice, it has the concepts, it has the content there. And trying to tackle this big standard at once is just not doable. So here is an example map of this particular standard, and what you'll notice is it looks different because it's typed. Actually, to do it, you need to write it by hand. It really is a lot easier, but I couldn't show that on the screen, so I made a diagram of it. But what I did is I took each of the content parts and put them in a box and made them orange so that you could see how each of those parts exists. We need to address each of those 4 parts in probably at least one of our performance expectations. And then we need to include a practice and a concept with it as well. Now, it's totally up to you how you write that, and totally up to you which ones you use. You know what activities you do in your class. You know how to write them so that they match with your activities and they make connections and they're meaningful to students. But just don't forget to put each of the 3 dimensions in your performance. And I'll show you some examples of that here in a minute. But you can see how I did arrows to show how those concepts kind of go together. It might be that they need to know about change in particle motion before they learn about spacing or before they learn about temperature change. Those things are important to consider, and you as the teacher know that. Students aren't going to know that at the time before they've learned it. That's why you have to guide them in making the targets. But you can see how we've kind of linked the DCIs together with the practices and the concepts. So what we want students to understand from this PE, we want them to have experience with developing and using models and constructing explanations. So try to use those in your performance or your learning performances. You can see there, each of those blue highlighted parts are those practices. We also want them to understand cause and effect relationships by examining them and identifying patterns and looking at scale, proportion, and quantity, and looking at energy and how it moves in and out of systems and how it affects the matter that's involved. And you can see that in the green parts there that are highlighted, and what parts of the content go with those particular concepts best. And then finally, with the content, these are the main content pieces with a little more detail, how you might word them than just the statement themselves. What is it about kinetic energy? Well, they need to understand why kinetic energy is a measure of the average temperature change of substances. What makes it that? And how a change in kinetic energy or particle motion is directly proportional to temperature changes. And how a change in particle motion can cause a change in the matter state, or how the state of matter differs in particle spacing location relative to other particles. That's the science you want them to get from the experiences you give them to do. So each of those can be broken down into a different learning performance with a practice, with a concept embedded with it. So you're going to write smaller targets, 3D learning performances with these components included. And I'll show you some examples. Develop a model to represent how a change in particle motion of a substance is affected by temperature changes in different pure substances. You see, that's manageable. That's something that you can design activities for, that's something students can wrap their minds around, and they can see that they're actually doing that when they do the explorations, the investigations, the activities that you give them to do. Same thing with this one. Explain how kinetic energy is important in determining behavior of matter. You can give them something to do, to explore, to figure out so that they can meet that performance. A couple more. Develop a model to explain how states of matter affect particle motion of a substance. And develop and or use a model to identify how number of particles in a given space is affected by the states of matter of the substance. All of those are small, targeted learning performances that you could easily give students activities to do to meet them. Now you see, when you take all 4 of these and you put them together, you could probably meet the big standard. Now you might have some gaps, but you're going to identify those and fill those in. These aren't perfect. You could probably find some other ways to write them better, make improvements to mine, or see something that I didn't even see at all. But remember, when you look at all of the specific learning performances together, those 4 or others that you create, you should help students better meet the big performance expectation instead of just that big, broad idea. This one, they can meet them in steps of smaller targets. So how does this connect to what we talked about in the first video about involving students in developing the targets? Well, you're still going to do that. You're still going to engage them with the phenomena, get them to ask questions they have about it, write those questions down, get them to decide what it is they need to figure out. But you're guiding them to the questions that you want them to go to, and then you're guiding them in writing the target in the way that it needs to be written. You're still helping them, but they have a stake in it. They have an investment in it. Their curiosity is a part of the process. You're not just giving them a target on the board and saying, here, this is what we're going to learn. You're giving them an experience so they can ask questions that come to them, and you guide them to find out the answers to those questions. You're still involving students in the whole process. Okay. As I close, I'm getting ready to be finished. I want to mention about assessment, though, because that's really important in making sure that the students learn what it is our target, what we want them to learn. So this is how we know if the target is met or not. We assess them. You can do formative or summative assessment, and this will help you to align your assessment tasks to learning performances. You want to make sure that your tasks do measure what you've asked students to do. You want to make sure that what you ask them to do help them meet the target, and you want to make sure that the task is aligned to the target. It all has to fit together. If there's any kind of disconnect, it's not going to make sense to the student. It's not going to make sense to you, and you're not going to really know or see what it is they've learned that you want them to learn, and you're probably not going to have any idea if they can meet that standard or not when they're asked to, right? So we have another related workshop opportunity that we've worked on, creating 3D assessment tasks in science based on the NGSS and the Kentucky Standards for Science as well. In that workshop, we use task formats, documents that have already been created that are helpful, that provide you with some strategy, with some sentence starters, with some things that will help you get started in writing tasks that are aligned to your targets based on the practices and the concepts that you have involved. We can write formative ones that will help you measure the quality of the activities you're giving students to do, so you know if they're actually good activities to meet that target, and you can tell whether students are getting it or not. And then we can also practice writing some summative assessments so that you know if students have mastered the science, mastered the practice, mastered all of the things you want them to know, mastered the standard, and then can they apply that to new contexts? Because we know that in the state summative test, they're going to have to apply the practices, the concepts, and the content that they've learned in your class to a new context. Can they do that? So, thank you so much for watching this to the end. I hope it was helpful to you. I hope it's something that you can take and use. If your school or department wants more assistance on this topic or any other, please reach out to us. We'd be glad to come and provide something customized for you or answer any questions that you have. Again, I hope this was helpful. Thank you.